is not half. No. What is a radius?
Distance from the outside of the circle to the center point.
Correct. The radius is the distance from the center of the circle to the outside edge of the circle. Okay? So a radius is literally described as the distance from the center of the circle to the outside of the circle. You guys know what that looks like. You know what it means. Radius. Center to outside. Okay? What's a diameter? Wrong. That's a chord. Okay? A diameter is a segment that goes edge to edge through the center. So this would be a diameter because it goes through the center of the circle. Now, there are segments that exist that go edge to edge.
Called a chord.
That's called a chord. A chord is a segment that goes edge to edge and not through the center. Okay? So is a diameter a chord?
Yes.
Yes, a diameter is a very specific chord that goes through the center. We get to play these fun games like, are all diameters chords?
Yes.
Yes. But are all chords diameters?
No.
No. Oh, I love my life. Okay? So, radius, we all kind of know that one. Center to edge. Diameter, you're pretty comfortable with that one. Edge to edge through the center. Chord, just edge to edge. Okay? It can go through the center, it cannot. Secant. Huh? Secant. A secant is like a longer chord. A secant is a line that goes through a circle. So a secant is a line that goes through a circle. Now, all secants contain chords. A chord is the part that goes edge to edge. The secant is the whole line. So radius is a segment, chord is a segment, diameter is a segment, but secant is a line. Following? Yeah? Still fun? And then a tangent. Y'all know what tangent is. Nope. It's no longer a trig tangent. Now it's a circle tangent. A circle tangent is a line that intersects a circle at one point. So it's like a secant, but it's outside the circle. A chord is edge to edge. Alright, so we're going to live our life pretty much right here today. Does that make you feel a little better? Yeah. Alright, as we get to, Unit 12 is chord, secant, and tangent. Just good to know what they are. Alright, so, what's an arc? So an arc is a bent line. So if I was going to talk about a circle, an arc is just a portion of the circle. That's not really super crazy. And then we have very specific kinds of arcs. Okay, a minor arc. What does that sound like? It's a baby arc. Baby arc. Okay, it's anything. So minors are always less than 18, right? They're all minors. So a minor arc is anything that is less than 180 degrees. So a minor arc is anything less than half the circle. Minor arc less than 18 times 10. And that's the best I can do. All right. Minor arcs are less than 180, and super specific, minor arcs are always named by 2 letters. Alright. AB would be a minor arc. You know it's a minor arc because it has 2 letters. And then major arcs.
Greater than.
Major arcs are greater than 180. and they're always named by 3 letters. So the 3 letters specifically denote direction. Okay, we'll get to that in a second. And then semicircles.
180 degrees.
Exactly 180 semicircle. Also have to be named by 3 letters. Have to be 3 letters. Alright, so where we're living today is naming arcs, like name it arc AB, name it arc DC, distinguish between major, minor, or semicircle. And then once we kind of get that hammered out, we'll talk about the actual length of an arc. How far around the circle is it? So a lot of this stuff we'll hit time and time again. So we're going to skip that. I don't want to do that. Talked about that already. Here we go. So it says we have circle P. You see circle P? Why is it called circle P?
Because P is the center.
Because P is the center of the circle. Okay? Now, I want you guys to name 2 minor arcs.
UT and QU.
Oh, I'm sorry, what?
I think 2 minor
Arc, UT.
arc UT.
That is this arc right here. Is that less than 180? Okay, perfect. Name another minor arc. Arc QR. That's this arc right here. How do you feel about that? Good? All those arcs are less than half the circle. 2 major arcs.
Arc RS.
Nope.
What?
Okay, so we say arc RPS. Now we never use the center of the circle to name an arc. That'd be naming a sector.
RUS.
Arc RUS. So specifically, arc RUS goes like this. RUS. Is that more than half the circle?
Yes.
Yes.
Arc TRS.
Arc TRS. TRS. So that is everything but baby arc TS. Can't write that. Major arc. Is there anything I can clear up for you on that, or is that just confusing for you? Why did I not go arc TRS?
That'd be a full circle.
That's just circle P. It's not really an arc. Does that kind of make sense? So the letters really denote direction. Okay, so yeah, there should be a small disclaimer here that says assume that RT is a diameter and assume that QS is a diameter. Okay, I'm going to throw that out there. So now I need you to name 2 semicircles. Okay, TR. No.
Wait.
No, you said it. Stop. Pause. Teachable moment. Coaching point. Arc TR. Is that this arc? Or is that this arc? It's technically both. So you need to specify which one you're talking about.
TURS.
So TSR is this arc over here. TUR is this arc over here. All right, that's why you have to have 3 letters so it knows me which half of the circle you're talking about.
Wait, is TR a full circle?
TR is a diameter. Arc TR does not exist.
Oh.
Arc TSR exists. I love my life. Right? So that's why you have to have 3 letters here. So name a different semicircle that we haven't already talked about.
Arc QUS.
QUS is the diameter, and you can say QUS, QTS, STQ, doesn't really matter. That's the first part of your homework. How do you feel about that? Yeah. Let's talk about it. What do you like? What do you hate? What's that? So here's where this is going. I'm going to ask you to find the length of arc QS. Ask you to find the length of arc QUS. Ask you to find the measurement of arc RT. Yeah? And this is all that stuff we talked about in Unit 2. The length versus the measurement. I totally skipped past this. How many degrees are in a circle?
360.
All right. Okay. Find the measure of each arc in circle A. When I'm asking for a measure, what are my answers supposed to look like? Degrees. I'm asking you to do this in radians. No, just straight up degrees. Okay? Every answer you give should be in degrees. What is, or how would you do this?
I would find the rest of the degree.
Okay, find the rest of the degrees. What do you have?
Angle A is 90 degrees.
Whoa, false. What are you talking about? There's 4 angle A's there. Please be more specific.
There's 4 angle A's.
Yes, angle A is right here, right here, right here, and right here.
Oh.
Angle A is 90. True. Angle is 103. True.
Angle WAX.
Right. Come on, we're in circles, bro.
Angle WX. Circle.
Arc
Arc.
WX.
90 degrees.
Perfect.
Confusing.
Yeah. Welcome to my life. Arc WX is 90 degrees because we're talking about circles.
Yeah.
This arc length describes that angle measurement. They're the same thing. So angle wax and arc WX are both 90 degrees. So that makes ZX a what?
Diameter.
A diameter. Think about it, okay? Where are you at in your process right now? We have 3 of the 4 chunks described. Go ahead, Aaron.
Arc XY is 77
How did you get there?
because 103 and then 77, and if X or ZX is a diameter, then you have to, it's 180. Right?
If this is half the circle, it has to be 180, right?
Yep.
So this has to be the other half of the circle, it can add up to 180. Or the whole circle is 360, you can math all the way across. Okay? So you can add these 2 together. Now you can just start piecing parting it together. So let's look at what it's asking us. I'm going to erase my highlighter so you guys... WX. How big is this one?
90 degrees.
90 degrees. Cool? XY.
77.
Arc WY.
167.
193. Oh wait. No. What?
So 2 options here. Blake says arc WY is 193. But he's absolutely incorrect.
Oh, thanks.
Why, Blake?
Because there's not a middle letter. You don't know which one.
It's a minor arc. It has to be the smallest distance. It has to be less than 180. So arc WY is a baby arc. Do. 180 plus 77. I'm sorry, 90 plus 77. Yeah? That kind of cleared up a little bit? This is step 1 of a multi-step process later. Alright. Major arcs. Y, Z, W.
Now it's
Okay, so we're going to start at Y, go towards Z, and wind up at W. What is that?
190
193.
degrees.
X, Z, W.
180.
270.
Yeah, you got there a lot faster than everybody else. 360 minus 90 is 270. Remember that unit circle?
This is XZ. It's XZY.
Shame on us.
283.
Hold on. X to Z, then to Y.
Oh, 270.
Oh yeah, Baker made a mistake, huh? X, ZY is 360 minus 77. And then ZWX. It's not difficult, you gotta slow down just a little bit. Okay, so those are all of our angle measurements. Arc measurements, sorry. Okay. Circumference. The guy that invented the round table. Anybody? Can I tell you my new pie joke? Are you ready? 3.14% of sailors are pirates. Okay. Circumference. You have two options for circumference. Option 1. Circumference equals 2 pi r. New or not new information? Okay, or circumference equals pi times diameter. I'm going to ask you to calculate circumference today. But I'm going to ask you to calculate circumference in terms of pi. Does that confuse anybody? What do I mean when I say calculate circumference in terms of pi?
Like, don't use a number. Like, keep pi as a variable.
Do not multiply by pi. Pi stays in the answer. So let's practice that. R equals 4. Please calculate the circumference of a circle that has a radius of 4.
8 pi.
So the only thing that you multiply are the numbers. 2 times 4 is?
8.
So the circumference equals 8 pi. Yeah? Now, calculate the circumference of a circle that has a diameter of 8.
8 pi.
It's glorious, isn't it? 8 pi. The regular kids, I don't know what's going on. They're just intimidated by pi. So before we continue, if you have to write pi as all your answers, how do you write pi? Because you're going to write pi a lot in this unit. How do you write it?
Pi.
I like to do it like this, like the tilde in Spanish.
Oh, yeah.
That works. There's the lazy way, line, line, line. Doesn't really matter. We're cool. Practice with pi. If you want to get super fancy, you could. All right, that's technically what it looks like.
No, it's more like one-legged train.
All right, just practice. Okay, super complicated. What is the circumference of this circle?
6 pi.
6 pi. Again, right, this is step 2 of a multi-step process. 6 pi is the circumference. What is the circumference of this circle?
9 pi.
Okay, because I have a diameter now. So showing your work really slows you down. but it's good to see where it comes from. Is anybody confused on this one? All right, when I did this in first period last time, we did this. They cut the diameter in half and got the radius, and they found 2 pi r. Same answer. A lot of extra work there. Because they're more comfortable using the radius. All right, what about this one? 7 pi. Oh, Baker. No, not 7 pi.
7.
No.
I'll get
What is the circumference of the circle? What did you say it was?
7 pi.
Meters.
Oh
7
man.
pi meters. All right, so now we're getting into the measurements where your units matter. My bad, I skipped out on the first like 10 of them. Okay, word problem here.
Okay.
The wheel of a car is shown at the right. How far does the hubcap of the tire travel in one complete rotation? How far does the tire itself travel in one complete rotation? And what is the difference in the distance that the hubcap travels and the tire travels? So I'm putting this wheel on the ground and I'm doing one full rotation, which is asking you for what? Circumference. So I'm asking you, what is the circumference of the tire? What is the circumference of the hubcap? And what is the difference in their circumferences? So what is the circumference of the hubcap?
6 pi.
6 pi inches.
So from here to here is 3, and 2 pi r would be 6 pi inches. Now 6 pi inches is about 18 inches, right? 18 inches-ish. Now what is the circumference of the tire?
16 pi.
False.
Psych, I lied. Oh.
wait.
Remember, the radius is from the center of the circle to the outside. 22 pi is the circumference of the tire. 22 pi inches, which is about 66 inches. You can't just find the width of the tire, it's the circumference of the tire.
I was reading totally different.
So what is the difference between the circumference of the wheel and the circumference of the hubcap?
16 pi.
Yeah, with 22 minus 6 is 16 pi inches. Alright, so this is where I can nerd out about, putting bigger tires on your truck and smaller tires in your car and how it messes with your speedometer and how you're not actually getting worse gas mileage and all that stuff. Alright, but most of you guys are not interested in that. So in one full rotation, the tire goes about 66 inches on the ground. For the hubcap, it only goes about 6 inches. I'm sorry, 18 inches. So how can a tire travel 66 inches in one full rotation and a hubcap only travel 18 inches in one rotation? So like your tire's gonna be over here, your hubcap's gonna be way over here. How are those numbers different?
Smaller diameters.
They're a unit that's tied together, right? So it's just one rotation. So one rotation of the hubcap is 6 pi units or 18 inches. One rotation of the tire is 22 pi units or about 66 inches. So they're still going one full rotation, they're just traveling different distances. Okay, all that for this. Here we are. Why we're actually doing this. Now we're going to find the length of an arc. Alright, the length of it, not the angle measurement, but the length of it.
Are you there?
Baker pauses.
Are you there?
Hello. Yeah, she got a nurse to pass it around. Okay, thank you. So let me describe you what we're actually doing. You're going to get a circle, and you're going to have a couple pieces of information. It's going to ask you for the length of AB right here. So if you know that the radius is 4 and the angle describing the arc is 100 degrees, you have a way to find the length of the line. It's called an arc length. It is a portion of the circumference. So the book says that the arc length is equal to, so that would be, in this case, x. We don't know how long that is. That x is equal to the degree measure of the arc over 360 times the circumference of the circle. Can you mentally math the circumference of the circle? Or you can do it all in one. So x is equal to 100 over 36 times 2 pi r. Yes or no? Yeah, you like that? That's the book way. Here's Baker's method. Okay? I like to do cross multiply. I like to do this. So we have two different sides of this equation. We have a length over a length, and we have a degree over a degree. So what is the length of this arc? I don't know, x. But what is the length of the whole circle? The circumference. Length. Or 8 pi. Now the other side is degrees over degrees. How many degrees is the arc we're trying to find? Over how many degrees is the circle altogether? I like this way better. I like that way better. It works for sectors, it works for radians, it works for all that stuff. It's just two different proportions. Does that kind of make sense? So in this scenario, you would just kind of type all that in your calculator, and it's going to ask you to leave your answer in terms of pi. Not the greatest, in my opinion. I like to do it over here because I can simplify this fraction. All right, I can knock off the zeros. I know that works. So now I have simplified x over 8 pi equals 10 over 36. That's not bad, is it? Cross multiply, what is 10 times 8 pi? And x times 36. Then to get x by itself, divide both sides by 36. So 36, 72. Let's see. What goes into 80?
It's like gross.
29ths. 29ths? Sure? Believe me?
Sure.
So that's 20 pi over 9. Simplifying the fraction. Yeah? No? Maybe? So right now we're trying to find this length, and we're using a proportion. And I gave you a nasty number so you couldn't find any shortcuts. Let's jump to the next one. says, what is the length of the darkened arc? And leave your answer in terms of pi. So we're trying to find this arc length right here. So when we do that, we do length over length, degrees over degrees. What is the length of the darkened arc? X. What is the circumference of the circle?
360.
Circumference.
Oh,
30
2 pi over.
2 pi r. So we're doing part of the length over the whole length equals, how many degrees is the arc describing the circle? The arc. 300. This arc is 60 degrees. So what's left over for the rest of it? 300. So that's part of the length over the whole length equals part of the degrees over the whole degrees. I like to write it out just like that, and I like to simplify things. Well, this is really x over 30 pi. And I can simplify 300 over 360 to 30 over 36 or 5 over 6. Now, how am I doing that? Now, I should be able to mental map that. 60 goes into 300 5 times, 60 goes into 366 times. Your calculator will do that for you. But now look how pretty that is. That's not bad, is it? So cross multiply.
150.
So 150 divided by 6. Okay? 25. Yeah? 25 pies. So 25 pi meters is the length of the arc around the circle. What's the total length around the circle? 30 pies. Right? So if the total length is 30 pies and the darkened arc is 25 pies, how big is that piece? 5 pies. Or 5 pi. So if I was going to flip that and find the length of AB, little arc, baby arc AB, it would be x over 30 pi, I already know the circumference, equals 60 over 360. And you could simplify that down into x over 30 pi equals 1/6. Well, what is 1/6 of 30 pies? 5 pies, right? We're just doing percentages right now. It is 1/6 of the total circumference, which is 5 pies, because 1 times 30 is 30, and 30 divided by 6 is 5. All right, 3 different questions here. Find the length, the numerical value of arc VT. That's this arc right here. What is the numerical value of arc VT? We know 2 different pieces of information. The radius, or 3. The radius, the circumference, and the arc measure of what's describing arc VT. So I see people mouthing that this is 90. That's 90. This is 30. So that arc's 150. It's always wise to go in and fill your arc measurements out because you'll use them for the rest of the circle. So remember, when we're finding an arc length, it goes length over length. What is the length of arc VT? What is the length all the way around the circle? 2 pi 5, or 2 pi r, that is the circumference. It goes part of the circumference over the entire circumference equals the degree of the arc we're describing over all of the degrees in the circle. So you can cross your zeros out. Is there any way to simplify 15 over 36? You can do control divide. And it will tell you the most simplified version is 5 over 12, which is wonderful. So x over 10 pi is equal to 5 over 12. Now we cross multiply and solve for x. 5 times 10, x times 12. Divide both sides by 12. So we need to take 50 pi over 12 and simplify it. If that's too much for your brain, 50 over 12 and it simplifies to 25 over 6. Now, theoretically, you have enough information to find every other arc measurement out there without doing any other extra math. What is the length all the way around the circle? 10 pi, right? Yes? So, how long is that arc?
5 pi.
Half of that, 5 pi. So if this is half of the half, how long is this one?
2.5.
This one's 2.5 pi. Or you might see that as like 5 pi over 2. Okay, that means this one's 2.5 pi. So how long is this whole piece? 5 pi. But I have 25 pi over 6. So how do you get 5 pi and give it a denominator of 6? Multiply it by 1. 30 over 6. So if this is already 25 over 6, what's this one? 5 pi over 6. That's just using fractions to math all the way the rest of the way around. The whole thing is 60 pi over 6, right? Or 10 pi's. And you start fractioning out like radians. What's going on there? So we already did all of those. And the last kind of part here is using algebra to solve for arc measurements. So assume that xy is a diameter. How would you set up something to solve for the arc measurement of xz, or angle A, the variable A? How big is this half of the circle? So this piece and this piece equal how many degrees total? So then you just kind of combine like terms. And you get 52 degrees. That's algebraic arc measurement math. Alright, so what I want to leave you with today is make sure you have this formula somewhere in your notes. That's length over length equals degrees over degrees. It's a portion of the length over the whole length equals the portion of degrees over the whole degrees.
That's your method, right?
That's my method. The book way is the same thing. So in the book method, and what I did is I just divided both sides by circumference, so it gave me the same thing. They both work the same. One solves directly for it, the other one you have to do a little bit of cross multiplication. So we have a few minutes left. Your assignment today is page 456, numbers 1 through 33. And it is a graded assignment. So get that book out and snap a photo so you can work on it at home. Send it on the group chat. Not necessarily long assignments, not necessarily like super hardcore math assignments. So make sure you get those knocked out. We'll start with radians tomorrow. We'll move on to area and sectors. Page 456, 1 through 33.